Hi everyone, it is Devi, Professor of Electronics and Communication Engineering. In this video lecture, we are going to learn about Delta Modulation. On completion of this module, the learners can be able to understand the principle of Delta Modulation and the advantage and drawback of Delta Modulation with its applications. Delta Modulation. So delta modulation is the special case of differential pulse code modulation. So we have to know the basis about pulse code modulation and differential pulse code modulation. So in case of PCM, it transmits all bits which are used to code the sample. Hence, signaling rate and transmission channel bandwidth of PCM is very much large. So to overcome this drawback, we go for delta modulation. So delta modulation, it is to increase the correlation between adjacent samples of the signal. So this permits to use a simple quantizing strategy for constructing the encoded signal. So delta modulation transmits only 1 bits per sample. So it is a present sample value is compared with the previous sample value. Whenever the amplitude is increased or discrete to send. The input signal x of t is approximated to step the signal by the delta modulator. So here the input signal and the delta modulator signal both are compared, and after comparing these two signals there is some approximation. This approximation falls below the signal at any sampling approach. It is increased by delta, and provided it does not change to rapid change in the signal sample, it remains the same. So there is some plus or minus delta value changes. So simply we can clearly tell that is the difference between the input signal x of t and the delta modulated approximated, or it is staircase signal. Both are combined and it is confined to two levels, plus delta and minus delta. If the difference delta is positive, then approximated signal is increased by 1 step plus delta. If the difference is negative, then the approximated signal is reduced by minus delta. So here when the step is reduced, 0 is transmitted, and if the step is increased, 1 is transmitted. This is the basis behind this principle. That is, if 1 is transmitted, it is we can tell that step is increased, and if the step is reduced, 0 is transmitted. The principle of delta modulation can be explained by that's the difference between the input signal and the staircase approximated signal. So we have the basic block diagram of the delta modulator. For considering the delta modulated signal as the output, we have to give the sample input signal xn of ts as the input of one summer, and the another input of the summer is x cap of nts, that is the approximated value. So the difference between these two signals are considered as error signal, and it is noted as E of nts. So E of nts from this diagram, it is the equation can be written as that is equal to E of nts is equal to x of nts minus x cap of nts. This error signal is given as the input of 1 bit quantizer. The 1 bit quantizer compares every time inputs to plus delta or minus delta. So the output B of nts is given as the summer, and again x cap of nts is also given as the input of the summer. These two will be added, and the added output is U of nts, and it is delayed by the time delay circuit ts, and the delayed signal is again given as the input of the sample input signal with the summer. So in this diagram there is one accumulator circuit is there. So this accumulator circuit is nothing but the combination of the delay circuit and 1 bit delay circuit. Delta modulation offers two unique features, that is, no need to do word framing because of 1 bit quantized word, and simply we can design both transmitter and receiver with very simple designs. The receiver of the delta modulator is like this, that is, input signal, finally the output signal is the original signal, it is obtained from the modulated signal, input signal, and V of NTS, that is given as the summer, and U of NTS is the output of the summer, and again given as the input of the delay signal. U of NTS is given as the input of low pass filter, and it produces the original input signal. So here this delta modulated signal have one drawback, that is it will produce the slope overload noise distortion and granular distortion. The slope overload noise is nothing but the distortion when occurred when the desired signal falls below, and granular noise is the distortion that occurs when the desired signal that falls above. So we have one quiz question based upon this delta modulation. The question here is 1 bit delta modulation that is represented as 1 bit sample is transmitted. All code bits used for sampling are transmitted. One step size is fixed. Both A and C are correct. And while considering A and C, step size is fixed is correct. 1 bit per sample is transmitted is also correct. So all code bits used for sampling are transmitted is wrong. That is in case of PCM. So A and C is correct. The answer given in D is A and C are correct. So correct answer here is answer D. Both A and C are correct. Hope you all understood the basic principles of delta modulation. Thank you for watching this session.